All right, so we have a few more that we're going to do today. They're a little bit more complicated than they were yesterday. So like the ones yesterday, you had a number on that side, and now we have a variable. That's fine. Just leave it there. When the first step says to isolate the radical term, this is the entire radical term with the 2 attached. All right. Leave it attached. All right. You don't want to divide both sides by 2 because you'll end up with a fraction. And when you square a fraction, it just becomes really gnarly, and you're going to have to do like fraction busting and stuff. So you want to leave that 2 attached. There is a rule of exponents that we used a while back. All right. And your rule is that if you have 2 separate bases raised to a power, right, that they both get that same power. And so we're going to want to use that rule for this equation. All right. So your normal second step is to square both sides because that's the index, and that's what we're going to do. I'm going to square the left, and I'm going to square the right. And so when I square the right-hand side, because I have this 2, I'm going to want to apply that property. So on your left-hand side, you're just left with t squared. Can't do anything about that. But on the right-hand side, the 2 gets squared. And then when I square that square root, I'm left with that radicand, or the value underneath. So it's really important that you put parentheses around everything that's contained underneath the radical, so that way you can distribute. Right. So now you have no more radicals. When you distribute that 4, you're going to want to move all of your terms to one side so you can use the zero product property, and move them all to the left so that way your t squared stays positive. And now you're just looking for the product of 2 numbers to give you 4 and add up to be -4. And so the only way that can work is if you use -2 and -2 and -2. So it looks like you should have 2 options. You only have one answer. It's the same thing twice. And so I'm pretty sure that that's going to be my solution. I do need to just double check real quick. So I'm just going to go off to the side and check to make sure it works. And so if I plug that into the original equation, I get 2 on the left, and then it looks like this on the right. And that works. The square root of 1 is 1, and so that's going to be good. So this is your answer. So anytime you have a radical that might be attached with like addition or subtraction, or anything with multiplication, if it's attached with like something where you can add or subtract it to move it to the other side, then do that. Otherwise, if there's a number attached with multiplication, leave it alone. You don't want to do anything else to it. So this is your process. Questions, comments, things you want to know? No? Yeah, I'm going to make it a little harder then. All right, so I'll put a 3 in front. So similar to the last one. All right. But I'm going to have some extra terms. All right, so this one has your radical that I need to isolate. And I want to isolate the radical term, the whole thing. So if that's the term that has the radical attached, you need to move over anything that's not attached. All right, so this 2 needs to be moved to the other side. All right, it wouldn't matter if it's a variable or if it's a number. It still needs to be moved to the other side. And now this is in the same format as the last one where I have my radical. So I am going to need to use that last property over here. Right. So let's see. If I square both sides, the issue is going to be, again, on this side, I have a binomial square. And I believe yesterday we did them with addition. So you have a rule for the binomial square where it's subtraction. And so you're going to square the first, minus 2 times the product, and square the last. All right, the biggest mistake would be to square it and square it. All right, it's not the same as the last property. So if you want to use an area box, you can. You want to try to use the rule as much as possible. So the right-hand side, same thing. The 3 is going to get the square, and so is the radical from that last example. Oops. But then on the right-hand side, you need to apply this binomial square rule. So square the first, minus 2 times the product, square the last. And again, that's just trying to make it a shortcut so that way you don't have to do extra side work. If you distribute the 9, now this looks very similar to a video we watched yesterday where you have to move the 2 terms to one side. And on that video, he moved everything to the left. I'm just going to move everything to the right. So I'm going to keep 0 on this side. If I have a negative 4 right now, and I subtract 9 more, I get negative 13x. And if I have 4 and I add 18 more, I get a positive 22. But you can show the work of actually showing minus 9x plus 18 and do the columns that we've done before. Just trying to make it a little bit, shortcut it. All right, so now you need the product, 2 numbers to get a positive 22, but add up to be negative 13. So they both have to be negative, so I'm going to use negative 11 and negative 2. So it looks like I have 2 answers. I'm going to just double check because both of them could work. One of them could work. I don't really know yet. So I have to check them. And we have to check them in the original. All right. And so where this is what you're doing. Oops, that should be a 2. And that's going to work. All right, square root of 0 is 0. So really I'm looking at 3 times 0 plus 2. And that's good. All right, so right now 2 is good. And then I got to check the other one. But again, you can do this mentally. Oops. And that's also going to work. So I'm going to get 3 times 3 plus 2. All right. So you don't have to show your work on the check. You just have to somehow check to be sure that everything works. All right, on your homework, you have that back side that has all the answers, but you want to be able to still check it for practice, for like the quiz or the test or something. All right. I'm going to zoom out on this one. All right, questions on any of this that you're not sure of? Really, it's going to be applying these 2 rules a lot. And if you can get in the habit of memorizing that, it'd make things a lot easier. All right, I got one more small one for you. Just kind of give you a variety for the day. All right, so let's take the square root. You've got x squared minus 4x plus 9, all of that under the radical. And then I'll just write minus x equals minus 1. All right, same thing. You got to isolate that radical. In this case, there's nothing in front, so I don't have to worry about that first rule. But I do need to deal with the fact that this x needs to be moved over. When I add x to both sides, it becomes the positive. And so I'm going to write it in the order of the positive then the negative. It's going to make your binomial square issue a lot easier to deal with. Right. And then you can square both sides. So the left-hand side, super nice. Even though it's a quadratic, it's not too bad. Okay, same thing on the right. Square the first, minus 2 times the product, and square the last. And so you have a quadratic, but you have multiple quadratic terms. So if I were to subtract off this x squared and move it over here, they'd end up canceling each other out. And so I'm really left with something linear, and I just have to decide like where I'm going to move my variables. I like my coefficients positive, so I'm going to move my variable to the right, which means I have to move my constant to the left. And so you should get 8 equals 2x, or x equals 4. Now, like yesterday, we had one where you had a radical equal to a negative, and we stopped. That was only because it was the radical equal to a negative. All right? Having this extra variable or an extra number attached to it means you have to still check, and I had to keep going. So I'm just going to double check it really quick. All right, if I plug 4 into that x squared, I'm going to get 16 minus 16 plus 9. And so this is true. 3 minus 4 is negative 1. So even though I had a radical that was equal to a negative, because of this extra little piece right here, I still had to keep going. Oops. I like highlighting my stuff. Questions on this? Like.